Okay, hello. Welcome to the third class of data analytics workshop with Python. And today I'm going to talk about unsupervised learning. For the last class, we haven't finished it yet. And then it will be the supervised learning. And at the end of the class, I mean, after this one, you guys will have to update your project, what you are going to do. So at first, I think there is a lot of people here, but as I can see now, hello, okay. As I can see now, maybe you can spend so many time you want. So let's start with the first one. For the last time, I talk about clustering when you want to group the data point that have similar aspect together into, well, maybe any number. You can use this technique. I did show you the way to do that in Python with k-mean. However, if you go to this link, you will see there is a lot of algorithm. As you can see here, let me make it bigger. Okay, as you can see here, there is so many algorithms you can use it. Some oh, the microphone is not good now. Use the other one. Another one? Oh, I see. Let me try that. Hello. Oh, okay. Let me try this one. I think the system here is quite weird. I have to point this thing to that. I don't know what it's called. Probably. Hello. Okay. Sorry for technical issue. Anyway, this is a list of clustering algorithm that you can use from scikit-learn. Scikit-learn is the name of library in Python. In this library, there is so many kind of machine learning, and this is just example. You will see more. From the last time I demonstrated with k-mean, I'm not sure why it is now, but we have this thing, mini batch k-mean. And it is distance based. This image here show you how it works. The k-mean is actually distance based. This is a image of data point. Each dot is one data point plot into 2D plane here, and the color of each data point is actually what it actually is. Oh, it actually is the level of that data point, what cluster it belongs to. For example, as you can see, the first half is belong to the blue cluster, and the below one is belong to orange cluster. I guess the center of the cluster is here. We call it centroid, right? So if you use this land base, it will become like this. There is two clusters here. And if you use another one, for example, DB scan, which is density based, it will find a place where data point located together. So as you can see in this kind of data set, DB scan works well. This is a good example. In this link, I suggest you to read from this link, all of them. You will not just understand how to code in Python, but you can also understand the how each of them works. Okay, now I will skip this part because we already talked about it for the last time. Now, it is dimensionality reduction. Let's think about information now. Let's think about maybe you, your friend. How many data belong to you? For example, you here, maybe there is a location where you sit here. It can be defined as X and Y. And maybe your age is one of the feature, your score, your money, or anything else. There is so many information about you. Each of them, we can say that each of them is also a dimension of you. For example, if we talk about location, it can be a place where you sit. Let's say it's a X and Y in this room. So we can say that you have two dimensions. In two dimensions. At the last time, we also explore all faithful dataset. There are two dimensions here, which is duration and waiting time. We can plot it easily using scatter plot here. We can see how it looks like. But let's think about if we have more than two dimensions. Let's say we have three dimensions. It will be quite hard to plot things in three dimensions. Well, it's possible to plot things in three dimensions. You can make it in 3D plot, or maybe you can use VR headset to look at the data. What is the distribution of the data? Anyway, if there is more than three dimensions, let's say four dimensions, how are you going to do that? Maybe we can make a video clip. Let the time of the video clip be one of the dimensions. Or maybe you can use color or size of the cluster, or I mean the data point. But trust me, it's quite hard to, it's not work. So in this case, maybe you have to reduce the dimension of data. In this time, I will demonstrate how to reduce from 2 dimension. This data set has 2 dimensions, right? I will reduce this one into 1 dimension. Well, you can learn about it more from this link. It will show you some information about it. In this class, I will use PCA. Do you know what PCA is? I'm not sure Dr. Punjai had taught you about this one yet. PCA is a principal component analysis. Let me show you. Okay. Let's imagine that we have data set look like this one. That is data points here and 2 over there and 3 over there. Well, actually, this is the you in this class. And plot where you sit. So in PCA, it's trying to find another axis that span along that cover the most variant of the data here. For example, in this case, let me call this one x1 and this is x2. If we project this data point into this axis, you can see that in x1 is stored more variant than x2. However, I think we can find the new axis that can keep this kind of information better than x1. In this case, if we do PCA, it will create this line here. And another one will be look like this. Anyway, we can forget about the second line. We can just keep the first one. And then, oh, I think it's quite bad now. Hello? Hello, okay. So in this case, you just project the data point here into this line, and this, and we just remove all of them. Keep only the projection. Let me search the image about that one. PCA. Anyway, okay, this one is good. After you project the data point into this line, we can remove another dimension. We can reduce 2 dimensions into 1 dimension using PCA technique. And for example, if these 2 points located near together, after reducing into 1 dimension here, we can also say that these 2 points is also close together. Okay, in Python, we can use PCA from scikit-learn. At the first line here, you just import PCA. And then you create the object here. You also have to put how many components it will be. For example, if for the example here, there is two dimensions. This one, there is two dimensions at first, and I want to reduce it into one dimension. So we will reduce two components into one component here. You just put the number here, and then you fit your data set here into PCA, and then you just transform it. Now, the result from this line is the number after we reduce these two dimensions into one dimension. And I want to show you how well it works. In this slide, I plot the histogram. And you see, from the original dataset, there is two clusters here. But if you plot this dimension, it will not be separated well. Let me show you. I think this one is duration, and this one is waiting time. Okay. I haven't run it one before, so it might spend some time. Okay, after giving permission, I think it will go well now. Wait for a bit. Okay, cool. Now the data set is in two dimension, right? Let me show you, right? This one, if I want to reduce this one into only one dimension by just using this column, and then I plot histogram. As you can see, there is two hum here, but it is not separate well. Let's try another one. Duration. Well, it's better. Anyway, if you use PCA, well, in this case, maybe you don't have to use PCA, but if you use PCA to reduce it, you will get something look like this. Okay, and that's it. Let's see how things work in Mathematica. This is the code if we want to do that in Mathematica. In Mathematica, you can simply, this one is, hello? Hello? Oh, hello? Hello. Hmm. If you use that one if you want to do that in Mathematica, at first you have to put your data here, and then you just use the function dimension reduce. You have to specify um, how many dimensions remain, and then you just flatten it and plot the histogram. So you get this one. You don't have to specify which method you are going to use, but in Python, you may have to um, do that. In this case, I use PTA. Actually, there is so many methodology that we can use, so many algorithms. For example, in this case, I use PTA, but there is something called t and SOM. This is the name of algorithm that we can use to um, reduce dimension. Well, I suggest you to try to search that in Google. T This is T and another one is SOM. SOM, cell organized cell map, this one. Anyway, but in Mathematica, it will choose the algorithm for you. And in this line, I think in this case, we it just this code is just making the object that we can use it later. It's called dim reducer, and then we apply it into this kind of data, and it show you. I'm not sure what it is. Anyway, that's it for dimensionality reduction in Python. Okay, let's continue with the supervised learning. In supervised learning, the difference from unsupervised learning is in supervised learning, the data set have to contain some level. For example, if you want to classify the image between cat and dog, you have to have something like this image is cat and this one is dog. That is called label. In that case, we call it supervised learning. In Python, we have to specify the algorithm you want to use. And also you have to train the model and then evaluate it. I also put a link here so you can check. There is so many algorithms in scikit-learn package. There is so many things here. You can try to explore about it later. Anyway, before we go into that, let me show you how things work in Mathematica first. In Mathematica, you just simply import the dataset. In this case, we are going to import iris dataset. And in Iris dataset, there is 5 feature, 5 column here. The first one is simple length, simple width, petal length, and petal width. And the last one is species, which is the label here. In this case, what we have to do is to train model to get the phone number and predict which species it belongs to. To do that, we just have to turn this data set into different kind of format here. We have to put it into this form, like the first data set, the first feature, x1, x2, blah, 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 associate to which level. Let's say y1, like x1. You have to turn the data set in this format into this format. As you can see here in this line. After that, you will have to separate the trend test, because if you have data set and you put it into machine learning, train all of them, the machine learning will overfit to that data, right? I'm not sure have you ever heard about that one, overfitting problem? Okay. Okay. Hello. Oh, sorry. No. In that case, you may have to split your data. For example, if we have 100% data here, 100 record, we may have to split some of them as a testing set, and this will be trend set. Something like you this will be something like your homework, and then after that you study from this homework already, then we are going to have a test with some questions that you never see before. In this case, in Mathematica, we can use text drop here, and you put the number that you want to cut it. For example, this one, they want to cut at 75% of the data set to be training set. So they put 0.75 here. And then the data set will be split into 2 objects here. So now we can use it later. At first, we have 150 record. Now it becomes 112 as a training set and 38 as a testing set. After that, you just put the training set here using classify method. Now the model is already trained, and after that, you have to measure your main model Is it perform well or not? Actually, it should be image here. Let me run it. Okay, I think it's okay, I see. Now the Mathematica already trained some model for us. In this case, Mathematica will choose the one. Okay, can you hear me well if I don't use microphone? Okay? Because it's quite annoying when yeah. Anyway, Mathematica will choose the one that work well in this dataset for you. In this case, it's choose logistic regression. It is just one of the model. I will tell you what it is later. What is logistic regression? Now after we having a trained model, we have to test it. The way to test it in supervised learning, there is so many ways to find if whether this model is good or not. But in this case, in Mathematica, you can just create this object. You can use classifier measurement. It will return some kind of object. If you list the property here, you can see there is so many things. There is so many numbers. For example, as the first one is accuracy. Accuracy, let's think about it as if the number is close to 1, the model works perfectly on this dataset. As you can see, the number is 1, accuracy here. And I will script for the less, but in this case, we are going to use accuracy, confusion matrix, and RC curve. I think for the last time, Dr. Poomjai haven't taught you about this one, right? So I will talk about this. First, accuracy, as you can see, is 1. Like, if this model can do 100% correctly in this dataset. And for confusion matrix, it's actually a table that show you how the model predicts, how the model classify each data point. It will compare between predicted class, which is a class that generates from the model here at the x axis here, and the actual class is actually a label of that data point. As you can see, the one that model predict as setosa here is actually belong to setosa here, and there is 38 of them. And for versicolor, is also 100% correct here, as well as Virginica. And this is ROC curve. ROC curve is actually a plot between false positive rate and recall. Actually, recall is true positive rate. In this case, you see nothing because the line is 90 degree up. Is 100%. Is 100%. It is perfectly performed. But if you search this word in the Google, if you search this word in the Google, ROC curve, you may see something like this one. If the model have a very high curve like this, that means the model is perform better. For example, this line and this line. This one is better than this one. Anyway, in Mathematica, in this demonstration, we are going to use these three measurements to test with our data set. Anyway, I suggest you to not just test with the training set. In this case, this demonstration create this object from training set as well as testing set. Well, in training set, it should be performed well, right? Because that is the data that model already saw it. But for testing set, is it a data set that the model never saw it, never seen it before? So in this case, it's not perfectly it's not perfectly performed anymore. Accuracy is now 0.94%. I mean it's 0.94, but it is 94% in accuracy. When you have a look at the confusion matrix here, you can see some of them is mistakenly classified. For example, in this case, there is 2 data points that model predict it as Virginica, but it actually is versicolor. So, and for ROC curve, because there is three classes here. For ROC curve, there should be 3 graphs here. The first one is Sentosa, and the second one is for versicolor here. As you can see, versicolor is not perfectly 90 degree anymore, as well as Virginica. Anyway, if the problem is overfitting, when you plot this measurement, you will see that the model will perform well in tracing data. For example, maybe the model will perform well in training data. It can be 100% in accuracy, or maybe 98% accuracy. But in testing data, it may be something like maybe 60% or maybe 50. It significantly dropped like this one. In this case, we can say that the model is we face the problem, the overfitting problem. In this case, you may have to reduce the complexity of the model. I will talk about that later, what complexity of the model is. But you have to reduce the complexity of the model. But if the accuracy will be something like 30%, and for testing is maybe 20%. In this case, it's called underfitting. Anyway, this is how we this is the reason we have to test the model. This is why we have to do this thing. Anyway, in Python, it will work differently. Let me show you. Oh, okay. I think there is so many steps here. Maybe we should take a break for 5 minutes and we will come back how we are going to do that in Python. Okay.